Hello students. Now let's learn the Termwork 8 of the DALAB. The Termwork says find the minimum cost spanning tree of a given connected undirected graph using Kruskals algorithm. And it says use union and find algorithms in your program. Now you have already studied what Kruskals algorithm is in your class. So it is used to find the minimum spanning tree for a connected weighted graph. So the main target of this algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. And Kruskal's algorithm follows greedy approach. So I've studied what greedy approach is. So it finds an optimum solution at every stage instead of focusing on the global optimum. So here is the program. So in the program, we have written a find function. So find function is basically used to find the cycles in a graph. So what we are trying to create is a minimum spanning tree. So it should not have cycles. So we have to find whether there are cycles, whether by adding any edge we get a cycle. So we use the find function. So union function is basically used to create the spanning tree. So we'll come back to these functions. Now here you have the main function. Yeah, in the main function, we are creating an array A of 2 dimension, and here we say enter the number of vertices of the graph. So in the previous program, that is in the Dijkstra's program, you have learned how to input the graph to your program. So the same method is used here also. So enter the number of vertices. Then here we have to enter the weighted matrix. So we use 2 loops, 2 for loops. Then at A of ij, we input the weight. So we have to input the weighted graph. So we'll be entering the graph into your program as an adjacency matrix. Now after the input, we call this KRKL function by passing A and N as arguments. A is the array, that is the graph which is represented as an array. N is the number of vertices in the array. Now let's see what happens here in the function. So within the function we are using these variables, and as long as k is less than n minus 1, we perform these operations. That is, we are performing the operation for every vertex. That's why we have initialized k to 0, and we perform these operations as long as k is less than n minus 1. Then we initialize minimum to 99. We are assuming that weights of all the edges is less than 99 in the graph. So 99 is infinity according to us. Then for every edge, if a of ij is less than minimum, and if if I is not equal to j, then we have to assign minimum is equal to a of ij. So here I is, if I and j are equal to 0, that means you are trying to have a self edge. So we do not have any self edges in the graph. That's why while giving the input, we have to give it as 0. That is, if a of ij is less than minimum, that is, if the weight of any edge ij is less than the current minimum value, and if I is not equal to j, then we perform these operations. That is, we perform minimum is equal to a of ij. Then we are using 2 variables u and v for the vertices. So u is the vertex I and v will be equal to the vertex j. Then we call the find function first by passing u and then by passing v. Now the control goes to the find function. So in the find function, we are trying to find whether it forms a cycle. So first we pass the argument u and we call this function. Then we pass the argument v, then we call this function. Then ultimately it returns p, that is the parent of that particular argument, that is passed to it. Then whatever values returned from the find function is stored in I and j. If I is not equal to j, then we have to call the union function. So in the union function, we create the spanning tree. So if I is less than j, then we have to make parent of I is equal to j. Otherwise, we make parent of j is equal to I. Now that we have formed the union, then these are the output statements. So here is what we output, saying that from this edge, that is from the edge u to the edge v, we have this weight. We'll see the output later. Then we find the sum of all the weights of all the edges of the spanning tree. Then we output the sum. So this is how it works. Now here you have a sample output. Now the graph we are using for that sample output is this. So we are using this graph for the sample output. So we input this graph as the adjacency matrix. So I have already done it here. So it asks enter the number of vertices of the graph, that's equal to 5, and enter the weighted edges. So here I've entered. So you can see that the self edges are all 0. Then the maximum element we are entering is 99, assuming that if there is no edge between the two vertices, then we enter it as 99. So according to us, that's the infinite value, and all the edges are expected to have a value less than 99. Then once we input this graph, then this is the output we get, that is 1 to 2 is one edge, then 2 to 3 with the weight 2, 0 to 1 is the edge with the weight 3, and 3 to 4 is another edge with the weight 4. So these 4 edges will form the minimum spanning tree, and the cost of the minimum spanning tree is 9. Students, I've explained how the program is written, and you'll already know the Kruskals algorithm. So practice the program and try giving different input. That is, draw your own graph on the paper, input the values, and check whether the output is correct. Okay, practice. If there are any doubts, you can definitely come back to us. Thank you.